Hello everyone, good morning from the Novedge team. On today's webinar, we'll talk about straw-bale constructions and Vectorworks. Join us and Mark Stoklosa for an overview of rice straw and steel in construction. Get a little bit of the history of the use of straw bales and explore the projects by Mark's firm done by using rice straw bales and steel, all done using Vectorworks as a tool of choice. Mark Stoklosa has a master's degree in architecture and is also a licensed architect and has run a private practice for over 30 years located in San Jose, California. He's a Vectorworks Architect user since 1997. His specialties are, you guessed it, rice straw bale and steel houses and preschools. And here's Mark. And before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software. We offer huge assortments of software solutions that cater to virtually every designer's needs. So put us to the test and come visit our page at novedge.com. For more daily software news and promotions, you can always follow us on Facebook, Google+, and Twitter. Coming up next week, a webinar on Review Extreme, the complete PDF solution. Last but not least, today's webinar is free and is being recorded live. So if you want to rewatch this or any webinar episode in our collection, you just head on over to Novedge's YouTube and Vimeo channels. And now without further ado, I'm going to share Mark's screen and let him run the next segment. Take it away, Mark.
All right. Hello, guys. I hope you will enjoy my presentation. I'll be talking about architecture's intrigue, straw-bales and Vectorworks. All right. So that's my presentation. It's about me, Mark Stoklosa, Architect. I practice architecture in my own firm, Mark Stoklosa Architect Inc. in San Jose. Presentation objectives will be to learn about rice harvest and its global impact as related to the building industry, learn about recycled steel, outline the history of straw-bale buildings with examples, outline the straw-bale building code compliance approach, learn about straw-bale and steel use in buildings, and educate how to use Vectorworks in straw-bale based building design. The basis of my presentation will be Arroyo Commons in Livermore. It's a rice straw-bale and steel housing for developmentally disabled people, which we did in 1997. And then the Joe Residence in Walnut Creek, California. It's a rice straw-bale and steel two-story house. And the current project that I'm working on also in Livermore, which is a Romani Wellness and Winery commercial facility. It's about 20,000 square foot complex. Those who helped my inspiration, I need to give a plug to people who really were important for me in this, was late Dr. Carl Schultz, who had a hands-on inspiration for me in straw-bale with Adobe, and to think about it as a viable construction methodology. His son Gordon, who hired me to do this Arroyo Commons project, who said, I want to have this project so it feels good. And we did, I think, a pretty good job about it, and I will show it to you. And he embraced this creation of straw-bale and steel philosophy, and who traveled with me to New Mexico, Arizona, and Mexico, where we visited many of the straw-bale buildings, and who allowed me to pioneer our own straw-bale and steel solution. Then Bob and Lily Joe, who were my clients who enthusiastically built and designed by my studio straw-bale home, they reside in Walnut Creek. And Mr. Kashif Joshi, my client who is in full support of the straw-bale use in his Romani Winery Wellness Center to be built on a wonderful vineyard acreage. The project is currently on our electronic boards and part of this presentation. And the next one is the book that I suggest to every one of you to read, The Straw-bale House, by Athena Swenzelstein, Bill Steen, David Bainbridge, and David Eisenberg. This is a great and must read. Lots of information. You will find a detailed history of straw-bale structures, descriptions of various styles and techniques used in the straw-bale based construction industry. It narrates an excellent way in variety of issues and challenges straw-bale building industry faces. The authors were my inspiration to develop my own new solution using this fabulous medium as the straw-bale is. Special mention here is due here for California Straw Building Association, CASBA, a group of architects, engineers, building owners, and other professionals and volunteers passionate about straw-bale-based design and buildings. They are local here in San Francisco Bay Area. Check out their website, strawbalebuilding.org. They are particularly important since they promote straw-bale-based construction ideas with the state code writers, state legislature, and public. Their members have a large body of very impressive portfolio of work in many California and other areas. Their experience, knowledge, and talents are immense and pioneering. Anybody trying this medium as part of their design should get in touch with this progressive and avant-garde group of professionals. All right. So let's talk about rice production worldwide. This is a principal source of income for households around the world. Asia and Africa are a major source of government revenue. Rice is #2 cereal produced in the world. China and India, that have 1/3 of global population, consume half of global rice production. Italy is the largest European producer of rice. USA is the 3rd world producer. Brazil is the 2nd world producer. Current production levels are about 550 million tons globally. US has the best yield of rice in the world. It was developed at UC Davis, and they created this 5-inch water depth that produces the best type of rice ever. And there are thousands of rice grades worldwide. And what is nice about rice that it creates particularly wetlands, so it recreates a wildlife and rare bird habitats. Why should we consider straw bale? Because it is high silica content. It is resistant to moisture, rot, fungus, and mold. It is not edible for pests, termites in particular. In baled condition, it is inhabitable for pests. It's almost like barbed wire. Some straw found in Egyptian tombs survived thousands of years. Not suitable as feed for animals, nor compost. Complexities and problems with storage. Straw burning in California is prohibited since 1990s, so what is the farmer to do to dispose of it? High insulating value, R54 flat, R49 on edge. It is abundant worldwide, applicable for building in variety of ways from primitive to very complex. Any straw has been used successfully through centuries as viable building material. Now steel, recycled steel. Steel is the most recycled material in North America, Canada, and the United States. Steel has an infinite recycling cycle. Recycling steel saves energy, reduces emissions, and conserves natural resources. All new construction steel is recycled. A variety of steel recycled methods are magnetic, detinning. I am not going to spend much time on that. Recycled steel framing is about 260% more energy efficient than Energy Star requirements. CO2 emissions, steel framing 76% less than wood framing. Most studs are 90% of junked cars. Average house uses 3.6 to 6 cars to frame. Saves about 3.5 truckloads of logs being harvested. It's incredible. 600 steel cans are recycled a second. 30 million vehicles recycled a year. One car recycled 2,400 pounds iron ore is saved. 1,400 pounds of coal to melt it, and 120 pounds of limestone. There are some, it's part of the process. Steel framing waste can fit in an average household waste bin and be 100% recycled. Recycling steel saves enough energy a year to power 18 million homes. I mean, this is awesome. Now, history of straw bale in building. people through history used straws and grasses to build shelters. End of 19th century, here in the United States, a baling machine was invented in Nebraska. You know, in Nebraska there are no trees, no shrubs, nothing. It's just open space. So straw-bale shelter construction surged because they didn't have the material to build homes. So most of the structure exteriors were clad with use of mortar and adobe over the straw-bale. The straw-bale building continued during the interwar period. So here's my first straw-bale drawing of the Nebraska style straw-bale in 1886 to 1902. You have a simple truss or rafter system with straw-bales here and with interior plaster or adobe mud, and the same thing on the outside, and it was set on simple stone foundation, just rocks, you know, and in grade. And then for roofs, they just used sod. Whatever they had on site, they just used for construction as shelters. And also, I wanted to say that these structures actually last to this day. So that's amazing. And then the process of using straw bales in construction continued. In late 70s, for instance, Dan Huntington in Rockport, Washington, used straw bale with concrete post and beam structure. In mid 80s, John Hammond, an architect here in California, used a wood post beam and with straw bale. And this became an inspiration for enthusiasts in American Southwest. So then what happened was so-called a theme of straw raising. This is a community of enthusiasts who helped building the homes, mostly homes. This actually created a boom of sort in straw bale construction, especially in Arizona and New Mexico, and created a cottage industry of straw bale. In mid-90s, National Straw-Bale Research Advisory Network was formed. And in 1993, Tucson, Arizona, first straw-bale load-bearing residence was granted a building permit. Additional permits followed in Arizona and New Mexico. So here is this post and beam system where they had beam and post in there, and the straw bales with plaster on the outside, on the inside, and on the outside. They used those pins here, metal pins that would hold the chicken wire on the surface of the bale, and pin it together. Then they had a steel rod going into the foundation and some kind of rafter truss system for the roof with whatever roof covering they wanted to use. There was a moisture barrier, usually 26 gauge galvanized flashing type material, or some other like a visqueen, depending, you know, what people had, since it is a cottage industry and there are lots of people doing different things. There's only one theme that kind of goes through all of the drawings that I will show you, that elements from the outside like rain would seep through the plaster into the straw bale, and that's not a good thing, especially if you don't use the rice bale because of straw's composition, organic composition. This is another example where they use those bolts with little hoops here, eye bolt that were embedded in concrete, and then they would stretch the wire to hold down the straw bales in the wall with the harness of 2x6s and 2x4s, you know, keeping the wall together, and then again the rafter system would sit on top. So they use the cable like a wire rope or aircraft cable. It's amazing. I visited these places in New Mexico, and I couldn't believe the ingenuity of people who have nothing to do with architecture nor construction. This is another thing with the window, so you can set the window inside or outside, however you want. So you get this old world charm feel for the buildings, because we have these 6-inch walls right now, and the windows kind of on the outside. Here we get light and shadow. This is what architecture is all about. That's another idea. They had a PVC sleeve in the foundation, and then the wire went around to restrain the bales again on the foundation. This system used like a, I would say, header above the straw bales with plywood and 2x6s, and then they would nail on the bottom and top like 1x3 straps, and then put plaster on top of it on both sides of the building. But still, you have the water, you know, the elements penetrating into the bale. This this is another idea where they use this vertical truss between the bale layers, and they would support the roof structure, the beam, or trusses immediately on top. And then again the pins here, and the chicken wire, and stucco on the outside, and plaster on the inside. The plaster that the guys in New Mexico do are unbelievable. Those are enthusiasts who create their own formulations, and they were showing me for hours, you know, how it works. I mean, I was amazed, you know. This is great. Then you have a situation with concrete blocks, and straw bales are encased inside, and then again the roof system sits on top. There is always the moisture barrier on the bottom here, the foundation. And then there is a load-bearing straw bale where the enthusiasts began using, and I say enthusiasts in a very fondly kind of way. They are wonderful people. They had this steel rod going from the foundation through the bales. They would impale bales on top of it and then tense it on top, so it could be you know, more secure to the foundation. There is some shrinkage in bales, so they had to compensate for that beforehand. And again, the pins and the standard chicken wire with the plaster on both sides. Our neighbors to the north in Canada, they were also very prolific in straw bale construction. In the 80s in Quebec, Francois Tanger built a wood post and beam roof structure in filling between the posts with straw bales. In early 90s in Canada, Canadian Mortgage and Housing Corporation established grants to test applications of straw bale buildings in practice. In Canada, they have different systems. The Crown corporations sponsor a lot of good things that happen with this type of ideas. And then there was, thanks to this grant, Louis Gagné creates a straw bale and mortar mix system in towns of La Pêche and Chelsea in Quebec. And then Mr. Tanger and Michael Bergeron create a concept of concrete slab with straw bales. I mean, this is incredible. And then Francois Tanger built some straw bale homes in France utilizing Gagné's mortar bales. In early 90s in Canada, in Coronation, Alberta, I used to live in Canada, in Edmonton, for about 8 years. And so I understand the winters over there. So Mary Biggs built a load-bearing straw bale house there, designed by Helen and Jörg Ostrowski architects. What is the significance of this structure? Because it was located in the area of very heavy snow loads. So this is the Louis Gagné mortar matrix. So you have this mortar between the bales, and then they would put some kind of plaster on the interior and on the outside. This is like an elevation of our cross or longitudinal section through the bales with the mortar in between, and you can see the standard tool from Vectorworks how to create a shape like this. In the 90s, University of Arizona Farmer to Farmer program, check it out, it's quite interesting, inspired straw bale based structures in Obregon, Mexico. Program director Dan Dorsey and Thoric Sederstorm with Mujeres Actives de Castillo constructed women's group meeting building, La Casa Ecologia de Aves de Castillo. Same time, farmer-to-farmer program and United Methodist Church, I think Mexican United Church, sponsored straw-bale shelters in Mexico designed by Ms. Gomez. Straw-bales, bamboo trusses and top plates, stone foundations and so on. In mid-90s in Guatemala, Ezra Taft Benson and a foundation from Utah developed straw-bale initiatives. And in Finland, the guy Tapani Mariama built straw-bale house, not knowing that anywhere else in the world they were building straw-bale homes. I mean, in Russia, in Chelyabinsk, which is part of, I guess, Siberia, an American and Scott Pittman and Australian Bill Mollison built wood post and beam homes with bales. So this is what Ms. Gomez did with bamboo plates and bamboo rafters. And again, they used the standard chicken wire and stucco on the outside with some kind of moisture barrier. This is substituting bamboo with a concrete block on top and tensing it all down with the bar. This is another solution that I came along in my research for this presentation. The straw bales encased in a cage of steel and then ganited on both sides, and then some kind of steel or wood structure to keep the building. So the possibilities are infinite. So in California in 1995 in Chenoa, Mendocino County, a straw-bale load-bearing structure was built as a test site for wall shrinkage from its own weight. I went there and I saw that. It was designed by Bob Tice, architect, very nice fellow. The wall shrinkage was approximately 7 inches between pre-tensing the wall and roof loading. Excellent test study for approach to straw-bale construction. That's Bob Tice's wall, more or less. Again, the tensing bar, the plaster and stucco on the outside held, the chicken wire was held by those metal pins in here. So, but there was shrinkage. Okay, are we having fun? So, let's move on. So the codes. CMHC in Canada had the code straw-bale moisture load and thermal criteria. In New Mexico, they have prescriptive straw-bale code infill type of code section. In Arizona, Pima County prescriptive code for load-bearing straw-bales. In California, uses infill part of California code. Nevada has the straw-bale guidelines. Now, thanks to CASBA, there is Appendix S to IRC 2015, straw-bale construction with commentary. And what we have worked on, Rice, Bale and Steel, applicable solution for any code. So in 1995 to 97, a first vented Rice, Straw-bale and Steel residential complex approved by the standard building permit process, built in a very seismically active metropolitan area in the United States, in Livermore, California. And then the Joe residence in 2001 in Walnut Creek. It was a 2-story Rice, Straw-bale and structural steel with lightweight framing. And now we are working on a Rumani Wellness Center. These were designed and are being designed in my office here in San Jose. I had to take some pragmatic approach to this straw-bale. When I showed the building officials what enthusiasts were doing in the Southwest, they told me out of the gate, it's not going to happen. So I had to be pragmatic. I needed to satisfy my client to do the project, and we were sold on straw-bale, but I needed to make it safe for the codes. So I combined the recycled steel with straw-bales, rice straw-bales. So that's what we did. So this is like a plan. We have straw-bales in here. Then we had heavy gauge metal hot channels or studs on the inside with gypsum board on the inside face. That allowed me for electrical wires rather than between bales were between the studs. On the outside, the same thing, and then I could put plaster on the outside. That space here, the air space, allows me to keep the bales dry. And I can put any finish on the outside. It's not a rocket science, it's just being pragmatic, you know, in the approach. This is a design of top of the wall, again with the steel, structural steel, which is separate from the wall, with steel rafters. That's the Livermore Area Commons project. We were going to use straw-bales in the roof as well, but decided to opt out for recycled insulation. And then we used also a very light horizontal truss to be at certain levels. We used 2 of them in the wall to lessen the gauge of those tiny hot channels on the inside and outside, and it also acted as a load, wind load resistance. So the structural engineer actually suggested that we use that. So that's the bottom of the wall with the galvanized metal sheet here. Straw-bales are stacked up, the horizontal truss, and the studs in here, and plaster and drywall. This project has been built, and it looks pretty good. This is what we did on Joe's residence. It was a 2-story structure, again moisture barrier, again, and setting up bales on that. And again, the superstructure is totally separate from everything. And that's his roof system with straw-bales, again, horizontal truss. Venting was through those buttons on top of the rafters. This is another idea that we have created with structural metal studs on the outside, let's say like 6-inch or something, with a plywood, more of a traditional approach, with any finish on the outside, and then straw-bales set back, and then some hot channels on the inside, and gypsum board on the interior, or plaster, whatever you want to use. This is like a top of the wall condition, and this is the bottom of the wall. So it's pretty standard, you know, construction, nothing special, just using straw-bale for volume and insulation. That's another bottom of the construction if we use slab on grade type of thing. And we are doing some experimental studies for high-rise buildings. Hopefully we can create a curtain wall with straw-bales. So again, metal stud structure with the bales inside, and any finish on the inside, and any exterior finish on the outside. We could use even like a thin marble film over the aluminum honeycomb, which is very light, and then from the outside it looks like an awesome granite or marble building. So this one, another like a spandrel panel, and the panels could be something like that. So this is what I have no life, I guess. I design these things. So cons and pros. This provides straw-bale provides beautiful end product and tremendous comfort for the user. It is very inexpensive, virtually free. You can get bales from farmers for free, basically. It's very easy to build, often with straw raising, so people will come in and help you do it, no matter what project size, and it brings community together. It saves renewable resources abundant everywhere. Burning straw produces twice the amount of CO2 than is produced by power plants, 56,000 tons a million versus 25,000 tons a million. Straw bales are super energy efficient. 2x6 wood stud is about R3, insulated R19. An average 3-string straw bale has an insulating value of R54 flat and R49 on edge. 2-string bale has an insulating value of R43 flat and about R32 on edge. Sustainability. It grows constantly, always available and renewed each growing season as long as people eat rice. In addition, new rice fields promote wetlands and new habitat for rare birds as well as other animals. Each grain type can be best suited for growing area. Rice harvest renders the straw super sustainable material for building purposes. So here I list all kinds of pros, invented condition, it will last forever. It is resistant to pests and vermin. It adds volume to exterior walls. It is flexible. It returns to its original shape after 10,000 pounds force being applied to it. In seismically active areas, it will perform well as an infill, while steel structure compensates for seismic loads. It is fire safe in baled condition up to 2 hours with plaster on both sides by CMHC, and 35 minutes burning the face only, but not through the bale without any covering. Concern is the humidity and moisture. You have to maintain it at 14% to prevent the composition, mold, rot, and all these bad things that happen to organic material. Venting of installed bale is essential. Termites eat some straws, but not rice straw due to high silica content. So why straw bale? Conserve resources and energy in general, create sustainable construction methods, create lasting neighborhoods identity, combine various facets of industry into building process and shape a better environment for the users. And also promote healthy buildings. You can't imagine how cool it is to be in a building built in with straw bales. It's quiet, it's warm, you don't need to use any heating. And you have to think out of the box and have fun. We do. So design. Rice straw-bales as an infill material, engineered steel structural frame, lightweight recycled metal as key component for wood framing. Photovoltaics could be used as electrical system for energy. Fly ash as ingredient for concrete mix. And generating data and details while designing building using Vectorworks software. So lifespan, it's almost infinite. Ancient Egypt straw remain unscathed by time. Nebraska style lasted till this day. Countless buildings survive decades throughout the world. Steel renders structures virtually timeless. Bales protect steel from elements, and steel protects bales from impacts of structural loads, moisture, and damage. Okay, so our mission: offer a true green construction solution, promote the use of natural and recycled materials, reduce energy use for heating and cooling, decrease overall construction cost and life cycles, and all the other things, diminish the use of lumber in mainstream construction. So let's save the forests. Our goals is challenge status quo in the building industry, advance use environmental and eco-friendly building materials, design construction system that is environmentally responsive and safe, create new building methods, energy efficient, invent construction techniques that are cost effective to build. And that's, I'm asking you guys to develop even better systems than anything with the use of straw bale. So do it. It's fun. And construct buildings that are resistant and durable. And adapt Vectorworks to the process of design with Rice Straw-Bales. Okay, I've been talking. This is the current project in the Wellness Rumani Wellness and Winery. It's one of the floors in Vectorworks that the complex will be designed with. This is my 3D little rendition of it, of that first floor in here. So all these thick walls are straw bales clad in rock on the inside and on the outside. And this is a design type of a wall, so there are no layers inside. So that you're all familiar using Vectorworks, that this is a design for planners, for my client to look at, so there's contrast and so on. I give it certain thickness to show all of the internal layers of the wall. And then I want to create a straw-bale wall. So we are thinking to use maybe a tilt-up concrete wall, an air gap then the Straw-bale in green, and then the metal studs here on the inside with interior plaster or gypsum board. So that's how I create the wall, right? So those are all of the elements that we all know how to create in Vectorworks. And then when we created the dialog boxes that tell you, so the first layer would be this concrete wall. We know it's about 8 inches because it's a tilt-up, and we give it all of the information here. We get the lambda for Energos, which is a new feature in Vectorworks. So I'm working with the mechanical engineers to do the Title 24, the energy compliance here in California, and they need all that information. So rather than them figuring out, I already give it to them. So so this is my concrete tilt-up wall component core. Lambda, I look up for concrete and I get the information here. I give it a texture, I give it the line thickness, and we go further. And then we go to the texture. I still add something so it shows in my presentations. Then the description is Straw-bale barn. I have 3 buildings on site, so I call this wellness center a Straw-bale barn. So it's an exterior wall, load-bearing, and it has STC rating for acoustical 65. And then we add another layer here, which is an air, and again lambda 0. So we go through all of these processes, creating the wall object. So air, again, wall component, void, 1 inch. So we are all familiar with it. No texture. There is nothing in there. Then Straw-bale. So the wall component, Straw-bale. I give it a color. I created a texture. Again, I have fresh straw, you know, a little green for now, a little bit thinner line because it's not a core. And then again, for insertion options, you know, I give all of the information here, the class. So I have wall Straw-bale barn, you know, I have like a main class for that. And calculated R value from my lambda is R50. So they have a Straw-bale, compressed Straw-bale in there, or compressed straw in their database, but it's not really accurate, so I use something else. It's like some kind of insulation that actually per inch worked out similar to Straw-bale. So this is how my wall is beginning to shape. So I'm adding metal studs on the outside, and then I continue with my definition of my metal studs. I give it a little texture. I like to do that. I like to have everything real. So I know that I'm building my virtual building inside of my computer. So I look up again for lambda, and I give for gypsum board, for instance, a component like a stucco plaster. That's what I want to see on the inside. So that's how we look for those lambdas. You click here and you get gypsum wall bar, and you highlight it and you say OK, and it gets all totaled here. So that's my new wall. That's my Straw-bale building wall that we will be using on this project. And then that's how it looks. So I highlighted the previous all dark poche wall, and I say I want to replace it, and I replace it with a new defined wall for Straw-bale. So here, if I want to cut a section, so I create a new class. I usually do it under nodes as a SE marker, so it's section and elevation markers. And then I cut the section through the building, and I give it a name. I put on some sheet somewhere, and then that's what we get. So again, we see this 3D corner here of the building. That's an elevator shaft, so I don't know how I'm going to handle that yet. So that's my straw-bale wall object. You have the concrete, you have this air gap, you have straw-bale. I put them on edge, so they are 16 inches wide, then metal studs and gypsum board. And this is like a model of this thing. So it's concrete wall, the gap, and bales. You see I highlighted one of them here, so you can see each one of them. I can move around. I show it to the client, and he's just amazed. He was playing with the bales, putting them in a wall. It's really fun. so the project, the building will look something like that when it will be finally finished. So that's generated in Vectorworks with a HDRI background and all of the information that RenderWorks provides us in the software. So that's how the Rice Straw-Bale looks like. This is Al James, the general contractor who did the project in Livermore. We had 4 trucks of bales. So that's how they go into the building. So you see those metal hot channels on the inside, metal trusses here in the roof, and then we put some purlins on the ceiling, and then created this funky shape window. And that's how traditional straw-bale construction windows are framed. So I didn't want to invent anything different. I just used the methodology. The building was kind of Southwest style, which was mandated by the city. So so we used this thick frame for the windows to give this Southwest feel, you know, on the building. And then that's how you cut the bale. You see the strings here, so they have to be cut, and then you have to restring it. So we created a needle to go through, and it's just amazing. The workers had the best fun, you know, doing that, and I was hanging out on site all the time. This is how the baled wall looks like, with hot channels here on the outside. They were heavy gauge, I think 16 gauge, and it's all vented nice. And the windows were set back. We used bales 24-inch flat, so with all these other layers, the wall was about 28 inches thick. So we put the windows right smack in the middle. So on the inside you had a bench to sit, and the outside also a little indent for shadow. I love light and shadow in my designs, because that's the best thing to articulate architecture. And that's how the windows are put. You see the horizontal trussing here, and the moisture barrier on the bottom, and the tool to cut the straw. And then loose straw, whatever is left over, you just stuff wherever there are some gaps or nooks and crannies, you know, just to make the insulation work. So that's how the buildings look like. Those are like 4 units in one cluster. The project was for developmentally disabled people, funded by the federal government. We got an award for this. This project was initially rejected by the feds and by the city, by everybody, and we got kicked out one door, came back the other, and finally got it approved, and it stands since this picture was taken actually about a year ago. So it looks pretty cool after almost 20 years. So this is a truth window with the structure, seismic bracing in here, with and my client had fun, and he put little toy mouse in here. so that, and this is Joe residence in Walnut Creek. Also straw-bale house, 2-story. Bob Joe and Lily Joe are wonderful enthusiasts of straw-bale construction, and they wanted to create the retirement and zen kind of home in Walnut Creek. So that's how the wall looks like, you know, framed with all of the exterior studs and steel structure. It looks ominous and big, but it goes really fast. I mean, we had both projects framed in a week or so, you know, so it's no-brainer. And the steel again here, it's all recycled steel, so we are cool. So the Straw-bale allows you to do these neat things. He found a feature like that somewhere and put it in a wall over the staircase. And then Bob and Lily collect some bronze art, and so we created for them these little niches with light and the plaster on the inside. We use the Southwest plastering methodology for the interior. Okay, so that's about it for today. This is the data for my presentation. I list all of the things that I read or did in order to prepare this presentation for you. And thank you for attending. And if you need to contact me, that's my information here. That's my website and my email. Thank you very much, and if you have any questions, just let me know, and I will be happy to talk to you.
Okay, Mark, so we have a question that just came in. How do
Yes.
costs compare to conventional super insulated wall systems? Just,
Um, as a total cost, it's probably at par. It could be less because it's much faster to construct. We still build. Like on the Arroyo Commons project, we priced it out in wood and then in Straw-bale as a budgeting feature at the outset of the project, and we framed the whole 12 units in 6 weeks versus wood would have to be done in twice the time. So labor costs, would just go out the window. You can use less labor to do the steel construction. So it is a little bit cheaper.
wow, that's great. Great news. I hope, somebody's gonna give it a try and pursue this avenue with straw bales and recycled steel. It seems like you gave them a lot of resources and ideas of how to better do it and not make the same mistakes you did, and be persistent, and with permits and stuff, maybe they'll follow your lead. I'm gonna leave
I,
a couple of, yeah, I'll leave a
uh,
couple of minutes for, if somebody else wants to give other questions, submit them. We're here. And yes, do you
I,
want to?
I wanted to add something. The building official on the first project that we did, who rejected the whole notion of straw-bale, so I took him on a trip. We left like 4 in the morning. We went to look at different examples. I drove him, We looked at different examples of straw-bale construction, and he always said, no, 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 this, I will not approve this. And then I showed him the sketch what I wanted to do, and he says, yeah, I will approve that. So it took a lot of effort, to actually educate people. You have to educate in order to bring people along, and I think the CASBA itself, as an organization, they are very successful to be more holistic in their approach, where they have straw-bale as a load-bearing element or some other methodology, and they are more in front of the regulatory agencies, to get these things approved. I am more pragmatic, I just need to have things done, and so I look for solutions where I can combine green elements together and avoid headaches, So that's, I don't know if it is a right approach, but it worked for me. So I enjoy doing that.
Well, you do really think outside the box and you do whatever it takes. That's great. That's a great advice. So don't be shy and take matter into your own hands. If you believe in it, you can make it happen. Um, So somebody says, although it is an awesome way of construction, there's still danger of catching fire. How do you rebuke that claim?
Well, if you remember one of the slides, I talked about the fire resistance, and the Canadian Mortgage and Housing Corporation did studies on fire rating of straw bales. When rice bale is in compacted version, you know, when it comes out from the baling machine, it is so sturdy and so compacted that if you apply flame directly to that bale, it smolders only the whiskers that kind of stick out from the hole. The bale itself, it would take about a half hour to get to that point, and it wouldn't burn. In a dry-walled condition, it has a 2-hour fire rated condition, and you can see also pictures. If you read that book I cited at the beginning, they have a picture, I think, of the building of some barn that burned down completely and straw bales remained. So because of its density, how it is compacted, it's not going to burn. So, but you are not going to build the building with exposed bales anyway. So you will encase it in drywall or stucco or some other building material that will have some fire resistive properties. A wood stud, for instance, is wood, right? So it would burn. Then you put drywall on both sides, and then you have a desired fire resistance for the wall. Straw bale is only an insulation and a volume element. And of course, rice bale is so nice because it has these neat properties different than other bales like from the wheat or rye or more organic content type of bales. So I hope I answered that.
Yeah, and I heard it smells delicious too. Like if you
Yeah.
walk inside the house, you get this nice
Yes.
fragrant smell, which
It,
never heard.
it,
Aromatherapy.
yes, it's wonderful. You feel totally different. It doesn't smell like an artificial, not artificial, but a synthetic building, you know.
Yes. Yeah.
And it's so quiet. It's so quiet. You can hear your own heartbeat, you know. And the energy efficiency is amazing. Like on Arroyo Commons, I don't think any of the units used an air conditioning unit. So the HUD, Housing and Urban Development, required us to put air conditioning unit for each unit that we designed, and they are just sitting there rusting because we don't need it. You know, in Livermore, temperatures go to about 110 summertime, and before we closed the windows and doors, we were inside of the building. It was 73 inside, and outside was 109.
Wow.
So, and it was very comfortable. You know, it's a dry climate, so why not? And
Yeah.
in the winter, your body and your light fixtures will probably create enough heat to keep it warm. So I am totally sold on it. You know?
Wow. Wow.
Plus, you know, it creates this lasting neighborhoods. When you build with wood, eventually the buildings rot and go away. So the entire neighborhood is gone. But we need to create, people say, oh, Italy is so wonderful, the buildings, blah, 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 for so many centuries. Why? Because they created stone buildings and stuff. Here in America, we build with wood, and it's not lasting, so the culture kind of fizzles out. With this, we will have a permanent structure that will stay for, so the neighborhood, you know, how it looks like, it's unique footprint, you know, will be there. So you go from one neighborhood to the other. It's so nice to travel in the old world, right?
Yeah.
And look at the neighborhoods. Yeah, so we want to bring it here to America. We should start creating our own heritage. You know, it's very important.
That's a great point. That's a great observation. Thank you, Mark. Um, I'm still leaving some time for question. In the meantime, I will take the screen back and show my screen. I have another question that just came in. Any idea on availability in the Northeast?
Northeast. Yes, actually, straw-bale construction was done uh, all over the United States, even in the humid south. In Northeast, what you would need to do, uh, I would suggest stay away from other straws because they are too organic, you know, and you may have problems with deteriorating. Um, but definitely California Rice Commission and California rice growers would be very happy to talk to you, to send you the bales. You know, we got bales pretty much for free for the projects. So you would probably have to pay the transportation, and some people would tell you, well, you will spend money on a train, right? So there is that carbon footprint. No, no, don't worry about it, because the building actually you can achieve what you want to achieve with the bale. So that would be your first approach. Um, uh, I know that Texas is a large rice growing region as well, so you could get something from them as well. They are kind of closer relatively. Uh, and then check out your local farming communities which may have a product for use. And then steel is everywhere, and all steel is recycled. So you are there.
Wonderful, wonderful. I hope this gave everybody some ideas. And thank you, Mark, for your thorough documentation. That was wonderful. And I want to thank everybody for joining us today. And I want to remind everyone to visit our page at novedge.com, where you can find the entire line of Vectorworks products at the best price. And Novedge, in fact, is the best way to buy design software online. Come visit us at novedge.com. For information also on the latest specials and new releases, take a look at our Novedge on Facebook, Google+, or Twitter. And don't forget the next week's webinar is about Review Extreme, the complete PDF solution from Bluebeam. And to rewatch today's webinar or previous ones, check out our Novedge YouTube and Vimeo channels. And thanks for joining us again. See you all next time. And thank you, Mark. This was very interesting and informative. Looking forward to see many more straw bale houses around the nation. Bye-bye,
Yes.
everyone. Bye.
Bye-bye.